Okay, great. So we're live. Uh, a very good evening, everyone. So DevOps is not a goal, but a never-ending process of continual improvement. So I, Saksham Lamba, on the behalf of AWS User Group Dehradun, welcome you all on today's session on hands-on session on Docker and Kubernetes. The session will be not only introduce you to the subject, but will also give you hands-on experience and hence the session will be divided into two parts. In the first hour, we shall be focusing on the basic knowledge regarding the topic and just a theoretical, knowledge to give a basic insights of what it is all about. And in the second hour, it will be a completely hands-on session. So it gives me an immense pleasure to welcome our esteemed speaker, Mr. Girish Suri, who is a certified Azure Developer Associate and certified Kubernetes application developer. He has over 3 years of involvement with the fields of development, cloud native applications, design, and creating solutions, etc. So I'm really honored to host this session. So Girish, it all over to you. This stage is all yours. Thank you.
Okay, thanks Aksham for this wonderful introduction, I guess. So let me share my screen and just give me a thumbs up on the chat when you're able to see my screen. Okay. Okay. Are you guys able to see my screen? Just thumbs up in the chat. Okay, good. So the session today is all about the Docker and Kubernetes. So all of are like, I guess, from the developer points of view, all are in the developer, I guess. Yeah, I getting a very yes, good. Okay. So where Docker and Kubernetes. So firstly, I introduce myself. So I'm Girish Suri, working with Nagaro for last 3.5 years now. So my main motive is to basically working with the cloud native applications, creating solutions around the cloud native applications, deploying them, how to solve this problem with the technology, with the containerizations and all other stuffs, and you can say the cloud, Azure, AWS primarily. So in today's session, we more focus on how Docker and Kubernetes basically leveraging our capabilities of going cloud native for the various applications. Like what problem does Docker solving, what problem does Kubernetes solving, and how we can leverage that in our applications basically. So uh, any suggestion? Okay. So anybody use Docker and Kubernetes? Have any experience of that? Have any difficulty on that? Whether it is, so you can put on the chat. Like how's your experience with Docker and Kubernetes and all that stuff. Okay, so I guess we can start now and do that. Okay, so what is Docker? People really ask me, what is Docker? What problem does Docker solving? How can we leverage Docker? Is it useful to use Docker or something like that? So some basic generic questions we always ask to ourselves, like so. So basically, what Docker is it's an open source uh, open source platform for building and deploying the containerized applications. So it's I don't know if there's a big words, containerized applications, deploying and building. So what happens in a particular developing cycles, when you write code, you're writing on the daily basis, your developer writing a code. So there are various dependencies in their applications. Like if I take example of, for example, you are developing a Node.js application. So you are require many packages like Express, something JWT, and etc. All these packages. So all these packages are listed down in a package.json in your Node application, which is a package manager file sort of thing. So what Docker leveraging us with that, so all this configuration, like we have a Node applications and they have a different layers on top of that, like our packages, and then our application codes comes in. So like some people say that, okay, it's working on my machine but it's not working on your machine. What happened to that? So Docker basically solving that issues for us is creating a Docker file, you can say, which is all the dependency to creating that packages to the whole packages, which is basically have the all information regarding the application, where the dependency exists, how can you run that, how can you run that image is another buzzword in Docker. We will discuss in later what is image and what is containers and all the other stuff. So Docker is basically solving that issue for us. It basically packaging our application into a single entity so that, and it is shippable to every other system, every other user, or to the test environment, to prod environment, to staging environment. No issue for that at all. So it like creating a once, and then you are shippable to various environments and you can able to run it. So the developer don't have a fuzzy environment like it's going a issue that, okay, that dependency is missing, that dependency is missing. So people, start there. If a new developer comes in, so starts with he or she can start with Docker and have a no issue, setting up the environment, because everything encapsulated under this package. And it's also easy, to remove those packages from the Docker itself. So you can just do a CLI commands for that, and your system is again clean. So you don't need to go to the again to the various Google and install exe msi to basically install a new package and then remove it after you're done. So it's easy with Docker. You can just pull it out, and just when you have done with it, just remove from your system. It is that easy. So yeah, so it is Docker. Any questions regarding that? You can put it on the chat. Okay, great. No questions so far. So, yeah, I told about two terms like what is container, what is virtual machines, all other stuff. So when we are talking about the containers, so you heard a lot of times that Docker is a container runtime. We have a Kubernetes which is also leveraging containers. So everybody is moving from virtual machine to containers. But why this process happen? Virtual machines are great. It's not a doubt that virtual machines are not great. They are great. uh, so what happened in the previous, in a few years back, what happened is we deploy our applications onto our systems, and we have all the, operating system is there, then libraries are there, which is basically depending upon the applications, and then becomes our applications. So this has to be leveraged, the all applications have to be run in an isolated environment so that they uh, don't contradict other applications which are using some sort of a same dependency. So there is also, this arises a new issue, that dependency issue basically. So like for example, our application A is using dependency A, dependency 1, and our application B is using dependency 2, which are of same type. Sometimes they got they got contradicted with each other. Sometimes they are using same dependency, and you updated application dependency, but it's hamper the process of the application B. So it's created those applications are not much in an isolated environment, and that created lots of headache for the for the developers, for the deployment team, for the operation teams, how to handle this infrastructure, because they need an isolation environment for every application so that they can run in a single instances of it. So they come with a solution, like a virtual machine solution. So what they did in virtual machines, they have a bare metal. You can have a big server, one single machine, then they partitioning on the basis of any hypervisor, which is a virtualization layer, and on top of that they build up various various virtual machine of a different operating system. So rather than sharing a same operating system for all the applications, now each application sharing and another operating system of its requirement. Like if you are deploying an uh, a node application, you are using Linux or Windows, whatever it is. You are deploying .NET framework application, then you can you, you can use Windows Server. So, and Mac is also there, and various flavors of Linux, you can do that. So you can leverage that part, and you can deploy various virtual machines to each other, and they are in isolated environment in some extent. Now, when we go from virtual machines, working fine, but they require operating system within itself. So for every application you deploy, you need to deploy a new operating system. You have to create a new virtual machine for the isolation purpose. That's create a lot of headache. You have to deploy operating system, which itself take a sometimes hours to spin up. So when you basically deploying new applications of in your production environment, it take around 1 to 2 hours sometimes, because there are not many not because operating system take various time, a huge time to basically spin up and other and install dependency, and then your application get hosted, and they are connecting with the kernel of the hypervisor and other stuff. So here is the virtual machine, fails. Basically, it's not lightweight. It's very, very, very big, fuzzy. Sometimes it's create a GB of data to it. Then rescues come to the container environment, where Docker comes in a picture. So I will share you a diagram. I think that make more sense then. Yeah. So you can see in this diagram that how virtual machine environment on the left side, you can see how it works, and the containers are working together. So like in a virtual machines, in there are infrastructure is basically the, you can say, the bare metal, or you can consider as a machine which have a capability of computation. Infrastructure is just that one. And that infrastructure in terms of the production level have a big machines, like not just like our laptops, they are very heavy computation forces. So on top of that, there is a hypervisor, which is just a virtualization, so that we can create down various applications on top of this infrastructure to deploy into in any environment and can access it. So we can say above the hypervisor there are guest operating system, which can be any, and they cannot they are working in a very isolated environment. So guest OS 1 will be a Windows, guest OS 2 will be a Linux one, and on top of that there are libraries. So we are basically differentiating the isolations. So the libraries which is responsible for the app one are in the another application, and for the another operating system, another virtual machine. So and the same as it goes with app 2 over here, you can see. So in there's a bin library for app 2, which is have a totally isolated with the another bin library of application 1. So there is no contradiction or no chaos between, or no resolution. So operation teams or what management team can easily handle out the updates to any application, to app 1 or app 2, without affecting the another application running on another virtual machine, because they are working on an isolated environment. So now what you can see, there is a guest OS. So as I talked earlier, guest OS, basically operating system, basically take a huge time to spin up, and to creating those virtual machines take a very, very very type expertise. Lots of stuff is going on over there. You have to create NICs and all other stuff, and you have to leverage very heavy tools like VMware and all other stuff to basically spin up just a single application. uh, so what problem does a virtual machine comes up, container environment, you can say, try to resolve it. And when I talk about containers, you can see as a Docker container also. So it's a generic term for containers. There are another tools also like Rockets, container D, which is at the same technology based on the Docker. So when I say containers is a generic term, so it's basically that have a lightweight process environment. So now on terms of containers, there's the same infrastructure. We actually need that for computation. Then we have an operating system where our actual operating system is working. So in most cases in containers, you will find there is always a Linux one, Linux flavor, any other like Ubuntu, Fedora, etc. So like a VM, there is hypervisor. In containers, we have a container runtime. So what is container runtime is basically an interface where which provided the isolation between the various layers to the to the applications, to the operating system. So rather than connect directly to the operating system, those applications are connecting via container runtime, which is basically responsible for spinning up those containers, executing them, delete them, modify them, update them, and all the networking constraints over there. So if you want to connect with them, you can connect with their own network interfaces. Like we are basically have a virtual network interfaces on top of that. We will discuss on that in a bit. So container runtime is there, and then comes our library. So there is no operating system now. So if we are basically developing a particular application, for example, Node.js application, we don't need any sort of a operating system for that. We just need Node environment so that we can run our application on top of the container runtime, basically, and all the libraries, which all the dependency which have with associated with that application comes along with it. So you can say app and bin libraries become a container, which is just a package where you can have all the dependency, application code, and runtime, all the dependency available to them, and running in an isolated environment from another. Any questions regarding the containers? Why we are basically using containers and all virtual machine? Any question? I guess no. Okay, let's move. Yeah. So, what problem does Docker solve for us? Like we have seen that there are all virtual layers happen. Containers are on containers are sit on top of the container runtime. Then we have a different sort of a libraries on top of that, and our container actually is just an application code. So, like I said in a previously that virtual machines and the traditional environment where we have a single operating system, and on top of that there are various application, and then we have a virtual machine, they created a lots of fuss around the dependency issues. So Docker solved that problem for us. So we had adding another layer on top of the operating system, which is basically solve us providing the solution to deploy various application of same type or a different types, so that we can manage it by deleting it, creating it, or updating it sometimes, so that we don't need to fuzz about the various dependencies, and that basically that images are usable for in any environment, reusable in any environment. Like I have created a Docker image, which is basically a instance of which is shippable to the any other system or any other repository or any other environment. So that Docker image is basically shipped to the another person, another developer, which can run it and execute their stuff and do that and delete it, remove it in just a few seconds. So that problem, which is we have the dependency issues and all that stuff, solved by the Docker. So any question so far? Okay, our containers are not heavy. No, containers are not heavy. That's the beauty of the containers, that we have a virtual machines, they have a OS in that, so that actually makes them heavy, which is take sometimes 8 6 GB sometimes. But containers abstract that part, is basically using the container runtime to relying on the kernel. So that dependency which is come with the virtual machines does not come with the containers. Containers come with the runtime. And nowadays we have a sort of a slim slot of images, which are basically more light version. Sometimes it's an MB3, MB5, MB Alpine images and slim images. So yeah, containers are not heavy. I think that's answer your question, I guess. Okay. So again, okay, so now some of the terminologies you heard it, in sort of a hands-on, like what are Docker files, what are images, what are containers. So as we seen that Docker uses some sort of a uses some sort of a you can say configuration, where you have to design, where you have a set of a design give the reference that what need to be go inside my package. So that file where you have write all the stuff that okay, I need to build Node.js application, I have to do this, I need this thing in this application. So those whole configuration are written in the Docker file. Basically, we will see in a moment for that. So basically, the Docker file is just a set of instructions where written for the application, where you define all the dependency need for your applications. Like you need certain packages, npm install is there, restore is there. You can run basic CLI commands of a Linux one, and then exposing that applications. So Docker file is just a set of instructions which is need to create the, you can say, image, which we are coming on that point. So image is basically the output, you can say, of the Docker files. So when you build the Docker files, basically you build that set of instructions. The Docker will build that set of instruction for you, and after the output of that set of instruction is an image. So it's basically a package where all the instructions, all the applications you needed is reside there. So basically, image is a term which is basically a shippable to the any other environment for the user, for the for other purposes. So basically, image is a output of the Docker file, which is basically a runnable instance, so that you can run on your system or on the servers. And this image is basically represent the, you can say, the state of that applications. So now containers. So container is just a runtime of those images. So you have images, static images, which is basically a shippable to any other form. Like it's just like a dependency. So now you run that image. So that's when we are running that image is basically the instance that is known as container. So those containers are basically a runtime of the images, which is referent to it. So we have an image, and when we started to run it, it's become a container. So it's basically pointing out to image, and you can run as many as container of a same image. It's just not depend upon that. It's just a runtime interfaces. Okay. Any questions regarding this? Hemant Singh asking, basically a PaaS service. I don't think so. Means it's very debatable question. What you consider as a PaaS service for that. So it may be not. It's has some feature of regarding that you can basically it's leveraging some of the services from the Linux environment like C groups and namespaces. But there are many level of abstraction in the Docker itself, like container runtime is there and a lot of stuff there. So you can say that is a PaaS service also, but it's a highly debatable. So I think that make more sense. Any questions regarding the Docker file image containers? I have used AWS to build e-commerce back. I was thinking of CI/CD using CDK pipeline and AWS code build, maybe using Docker. Okay. Can we s- okay? Can we say that Docker allows us to create application which are platform independent? Okay, so here is a myth. You can good question actually. So there, when you asking for platform, are you referring to operating system, Linux or Windows one? Pranav, then I can make more sense to that question. Okay, let's I think is not replying. So yeah, so Docker allows us to create. Yeah, okay, so it's actually you are asking about. So when you create a image on top of a Linux, you can say you can't run it on the Windows, but you able to run, because now what Windows does is Windows comes with a small sort of a kernel in its system. So if you create an image in a Linux environment, it will be run on the Linux environment. If you create an image in a Windows environment, it will be able to run on a Windows environment, because eventually, if you see, the container runtime is talking to the operating system. So operating system is different from its APIs are different from any other. Linux have a different APIs, Windows have a different APIs. So eventually, if you build an image of Linux environment, it will be able to run on any Linux environment, on any of its flavor, but not on the Windows one, because the API which is container runtime is using is different from the any other platform. Is that answer your question, Pranav? Or okay, Sishan. So how Docker can help me here or make my life easier for ecom backend CDK setup? I have used, okay, so you have missed that question. I have used AWS CDK to build an e-commerce backend. Okay. I was thinking of CI/CD using CDK pipeline and AWS code build, maybe using Dockers. Okay, so yeah, Docker is basically can be leveraged in creating the backend services. Like if you have a CI/CD pipeline, and while you push the code, so you can create predefine a Docker file for that, and on a pipeline, basically you can define that whenever the code comes, you can run basically the Docker and Docker file, which is basically output as an image. Which can be put into that repository, which is able to deployable to your an environment like lambdas, app functions, Kubernetes, etc. So you can leverage as in that manner. Any other questions? Okay, Pranav say yes. Okay, and Jishan, that answer your question. Okay, let's. I think he's not replying. Let's move forward. Okay, here comes some more technical stuff. So it's basically the architecture of how Docker is designed. So is basically Docker is basically also designed in a popular, you can say, architecture like client server architecture. So we have a client where we have run the commands, and that commands executed on the basically on the servers. Here Docker host is basically the server. So on client we are basically executing the command like docker build, docker pull, docker run, docker tag, docker push. So all these commands will be run on the client, and these command talk to docker daemon. So docker daemon is basically, you can say, the brain of the Docker, which is basically orchestrating, not orchestrating, but creating those image, taking those image, running it, and deleting it, updating it, whatever instructions you gave to your client. So like if I write docker pull, so what docker pull is done is do is just extract the image from the repository to your local machine where you have run that system. So when you run docker pull, docker daemons take that command and see, okay, if that image present in my system or not. If not, then it go to the registry. Registry is basically the docker hub on any other registry you configure for your environment, and take that image and just pull it out and put it on your local machine so that you can run the instance of regarding related to that image. So you can see on that diagram that docker pool is getting that docker daemon. That docker daemon is pulling out the image of redis, which is a red one, and then this image is stored in your local repo, and then instance of this is getting running on your environment. So that's the whole architecture of how the client servers and registries works. Registry is basically the where you have stored all the images, artifactory like thing. Okay, any question on that? Okay, Ishan is asking it's CDK. Okay, okay, not a question, I guess. Any other question regarding the architecture and how this work, or we should move to the demo part, demo or hands-on, whatever it is. Cool, cool. So I think we should move on the fun part, which is hands-on. So let me let me share a link with you, which is I created, which I have an application which we will deploy so that. Okay, okay. Did you get the link? Any hands up in the chat? Help me out. Did you get the link? I just sent the links.
Not yet, Girish.
Okay, let me again share it with you.
Sure. Okay, I just received it. I'll just paste in the live chat.
Okay, good, good. Please do that. Okay, just just give me hands up when you get the link so we can start with the hands on.
Guys, I've shared the link. Has anyone received it?
Okay, did you guys get the link? You can put it on the, I think, thumbs up or yes in the chat so that I know that you get the link. Can we use Docker CLI in Windows sub Linux system? Absolutely, absolutely, you can use it. Okay. Session, are you able to put it? Me.
Yes. I guess I've shared it, but yeah, receive. I guess now the participants would be able to see it.
Okay. Yeah, yeah, I can see now. AWS
Yes,
User
got
Group
it.
India has a GitHub link now. So it's basically a sample application which is created for the hands-on purpose. Okay, so you can clone it. Take a yeah. So I will. Okay, got it. I will walk through you the application which I created. It's just a basic generic application written on Node.js application, basically on top of Node.js. Okay, got it. Cool, cool. So thumbs up for this if you got the link, and we can move forward with the hands-on part. Okay, so start cloning it till we start discussing the application, and then we can move to the Docker part. So it's not worry if you don't know Node.js or npm. It doesn't matter for this. It's just a simple application which is exposing a API on the data part. On the data, if you write data, it's just return you a key value pair. That's it. It's just doing that stuff. It's only for the demo purpose. I don't want to be fuzzy because I know some people are not from the Node background. Some people are from the different background like .NET, Java, Python, etc. So don't need to worry about on that part. So it's just an application. It's just that which is exposing a endpoint slash data, which is just getting a data. That's it. And here is the packet.json, which is basically a, you can say, where we have a dependency that what sort of libraries does this application require. So just require an express. That's it. So now here comes the Docker file. So as I said, that Docker file is basically where you have given the instructions what need to be done to your to your application to create that image of your applications. So here you can see that if you have okay, Tula is asking how to get on hands on. You can you can clone it your repository if you have installed your Docker, and we will run one by one that how you able to do that. We will run the commands with you. I'm just telling the application which is I created that so that you know that what's going on those application before you starting with the Docker. So yeah, again to the Docker file. So what Docker file is residing the instruction you need to deploy you ship make a application shippable. So in if you open any Docker file, from the world outside from the internet, you will see this statement always from. So it is basically from is basically the statement like what sort of application you are deploying. Are you deploying a Node one, Java, Python, Ubuntu, etc., all that stuff. So it's just providing a base image for you, that with a base image, and on top of that you put your dependency, etc., all this other stuff which you want to in a package of whole the image. And this basically from image is basically helping you out to create a is another Docker image basically. So if you had the Node 13.11 Slim, it's just another image which is reside in the Docker Hub repository from the official one. Let me show you on the Docker Hub site. We are the Node. So his is the official image of Node, which have a different tags. We will discuss later what about this tags, what are these tags basically, what how they help us. Yeah. So this basically, let me open that. Yeah. Second, last page. Okay, here it is. So yeah, so you can see the for statement, which is basically the statement requires to basically get the base image for your application, and on top of that you can recite your all the dependencies. So like we said, we are developing the Node application from Docker. So we are using Node, which is the basically the base image, and then the version of it, which version you want. Like there's a new version coming all day long, like in Java, .NET, Node, Python. So you have to represent the basically the tag is basically this one after the colon, which is representing that what sort of official image, or what sort of a part of that image you need. Like if you have a version 14, then you can write Node 14, 13, 8, 9, etc. And there are also other like Alpine, all the other stuff which are basically okay. Please increase the okay. Okay, sorry for that. Let me increase it. Okay. How to increase it? I actually don't know. Increase the size of any okay, control plus plus. Oh, thanks.
You can do my control plus, Girish. Yeah.
Yeah, I got it. It is visible now, or you need more? Is it great, Saksham? You can answer me on that, I guess.
You can do a little bit more so it's clearly visible to the viewers.
Okay, now it's
Just hold
great.
on. Yeah, works.
Okay, okay, cool.
Guys, it's
So
if it's clear, just comment in the chat. So
yeah,
yeah.
please point it out these things. Otherwise, there's no meaning of that session. Clear. Okay, it's clear now. Okay, I got lots of thumbs up. Yeah. So the from statement is clear to you all, or do you have any doubts regarding that? You can put it on the chat. Yes, okay. So like from statement is clear, this is just a base image which you need to perform the instructions on top of that. So here's come the next statement. You will find it very similar, like work directory. So basically what happened is when you created your image, you provided the base image. Now you need to deploy your source code which is resides on your system to that image. So for that, you are just creating a working directory where your code will be get, so that you can maintain the systems. So can you maintain the basically the file system on the post similar path. So work directory, what does it just do is it will set the work directory to the whatever you provided to it, to the related path. If it's not there, it will be create new one. So when the you write work directory user source app, it will be create that work directory, and it's just do the, you can say, the cd statement, change directory statement, and get now the cursor, you can say, in the image inside where you're running, it's pointed to this app. So after that, we are just copying package.json. So this package, basically package.json, is the file which is in my system, which I need to package. You can see the over here is the package.json. So what I'm doing is I'm just copying this packet.json and put it into the current working directory. So dot is over there. It's mentioning, it's regarding as the current working directory in that image, not in our system, in that image. So what happen is, when you run this Docker file, get the node version, then set up a new working directory on top of that, and then just copy that packet.json from your local machine to that image. After that, we are just running run npm install. So what happened in regarding run npm install, it's basically downloaded all the dependency which resides in the packet.json under that image, not on your local machine, under that image, so that you can package it. Now another statement is copy. So copy is basically, you are now basically copying your source code where your actual application code resides, like server.js is there. So it's just copy it and put it into the all the files which are present in the directory, copying and put it into the image. So that's one is copy dot dot. One more thing over there, you can see there is another file known as docker ignore. So what is this file resides is, this file is just do the stuff, as I mentioned, that you copying from your local machine to the image. So if you want some files not to be copied from your local machine to your image, because it eventually make the image heavier, you can write that folders, that files in your docker ignore, so that those files don't get into the image. And this is a very crucial aspect, because I seen various developer does not doing that stuff, and eventually what happens is their application, their image gets heavier, their size is increased, which eventually put lots of pressure on various different aspects on the networking layer as well as in running that. So you don't need those files, like you don't need log files in your containers, you don't need node modules. Firstly, you can install it inside itself, and you don't need git files. Basically, you don't need git files in your docker image. So yeah, so every time you create a docker file, also add docker ignore with it. So now after that, just copy it. I just exposing port 8080. Basically, it's my application which is running on the port 8080 basically. So it's depending upon the application what sort of a port you are exposing. I am exposing 8080 just. So I'm writing that no, I want to expose port 8080 from this Docker image every time I run it. The application will be listen at port 8080 to basically handle those REST APIs request. And finally, node server.js is basically the command which we use for run that Node.js application. Any questions so far on this Docker file? You can put it on the chat. No question. Okay, good. It's something clear, or everything is clear to you guys? Okay, so now we are moving to how we are basically building up those Docker images from the Docker CLI command. Is it? Let me clear it first. Is it clear, the CLI prompt, or it's you should I should or should I zoom it? Okay, package.json is basically
Uh,
yeah, yes, Saksham.
yeah, like I was just saying, if you could zoom a little bit, it would be like fine.
Okay, yeah, just tell me where to stop.
Sure, sure.
Does it look fine now?
Yep, looks good to me. Guys, if you think like if it needs more zooming, so you can just list it in the chat. Else
Okay,
it's
okay.
good to go.
Okay, so I have two question. Package.json, what's inside it? Okay, so package.json is relevant to the node developers basically. If you don't, it's just basically have the various dependencies, who is the author of that, how the scripts files basically, that how should I start the application, how to build those application, how to run it, test. So there's a lots of command for that. So package.json is just basically you can say the template what in the project itself, how the dependencies works it. Zoom it. Okay, let me zoom it more. Now this look fine to you? Is it like metadata? Yeah, sort of metadata, not proper terms is metadata for your application, but yeah, sort of. That is cyber dependency. So it's basically the node application how it's doing that stuff. So another question is Docker desktop needed? No, you don't need Docker desktop. Docker desktop is just for the Windows user. Sometimes I don't use Docker desktop basically to work with Docker. You can use Docker CLI itself. Docker desktop is basically the, you can say, UI version of the Docker. You can see all the containers, images in your system in Docker desktop, but it's get, I think, licensed now, so it doesn't make sense. Okay, so I'm able to see. Okay, so I think it looks very much clear. So let's build those commands. Okay, here are VS Code. Here are Docker files. So now I need to create application from this Docker file, which is doing the all this stuff. So there is command for that. You can do it myself. That Docker build tag, and you can say AWS User Group one. So I will explain it little bit by one. So Docker is basically just to representing that we have to run Docker command. Docker build is basically sorry, Docker build is basically instruction I'm giving that you need to build a Docker file. You need to build image from this Docker file, and after that there is a statement dash d, which is representing the tag. So what will be the name of that image, which is basically the output of that Docker file. And dot is basically representing that I need output of this Docker file, which is currently in this folder. So if I show you ls, so here is our Docker file. So now I'm again running Docker build, Docker build tag AWS User Group one. It's basically the tag which I am writing one, two. It's any of the number or the string you want. So I'm just putting it one, and dot. So dot representing the current working directory. Okay, so you need to find it from here and just build it. So when I run it, it's basically, you know what does is what is starting doing is, so first is find that base image which is over here. Try to find out this base image node 13.11 slim in my system, in my local machine. And if it's eventually not get find it over there, then it go to Docker Hub repository, pull it out from there and just store it into my local machine, and then started working with all these steps. So yeah, so you can see then step one is from node 13.11 slim. So it's saying that, okay, I didn't find it. No, so it's now starting pulling from the library node, basically the Docker Hub, which I shown you. And then they say that, okay, this pull is completed. Basically, it's eventually pull out all the image from there. Now it started. You can see the steps over there. The step we are mentioning in the step one is just from node, is this that, and after that there is a step two, which is basically setting up the working directory where you want to deploy your code, where you want to basically reside in your Docker image, and it's just doing that. Then you're just copying it and then just run npm install. This error is basically from the npm install. Is not related to the Docker. Is basically that I'm using the not latest version, so it's giving me that error that you have a not compatible log file version with that. So it's just a warning, you can say. And Now, run npm install is basically install all the dependency which I mentioned on the package.json for my node application. It go to that repository of node npm and start downloading all the uh, basically all the dependency to my system to basically build up that image. Now where we are, okay, so now it's saying the one package is looking for funding is just that stuff, that output of the npm, and it's saying that there are zero vulnerabilities, which is again the step of the npm. Now another layer which is basically copying, so it basically copying that stuff to the image and trying to build that. Now it exposing 8080 port, and then we have a command line. Basically we're saying that if you run the command, then if you're not providing any command while running this image, then this command will be run node server.js. And again in so it's successfully built, and there is also security warning you will see. And don't get panic if you are running on a windows computer just like me. Like I say that in a Docker in Windows is basically comes with another kernel which is a Linux based. So what I'm trying to do is I'm creating a Windows sorry, a Docker image from Windows against a known window Docker host. So my host is basically the Linux one, which is comes in the Windows, but I'm building a application image from a Linux one. So it's just a warning for that stuff. So otherwise, you will not get if you are running in a Linux environment, or you are creating a Windows container from Windows image from your Windows system. So it's just a warning for that, that it may be, because both operating system are not same with each other, like in a file system, in some other scenarios. So it just gives that it might be hamper your packages, it might hamper your applications, that it does not come with the same permission, same stuff which you are expecting, and then you get that error. But yeah, if you using the Linux or the Docker one, it will not show. So because it's a generally is a part of the DevOps pipeline, where we have a dedicated servers to basically build up those stuff, so there you will not get those errors. So if now the application is built, so let me just Docker images, it basically lists down all the images you have in your system. Okay, sorry, I think I miss out questions. Okay, there's a question. Packet.json is just like a requirement. Yeah, exactly. For Python, yeah. Packet.json is just like the requirement.txt for Python. Yeah, exactly. So it where you have dependency, and you have for a Python a requirement.txt, and you just write pip, I think pip install from file name, and it's just all downloaded that dependency for you. Another question is, then can we do this? Docker build my app dot version y in Docker file. Yeah, you can do that, but that doesn't make sense. You can also specify the path instead of writing Docker file, because eventually Docker itself looking for the Docker file. If you see in this code, the Docker file does not have any extension. It's 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 self-explanatory that is a Docker file. So you can write down the path, and it will eventually build up for you. Find it and starting to build up for you. Then it is best to use Linux subsystem. I think I don't get your question, Jishan. Maybe I might hurt the. Okay, for best practice that recommended, it will use Docker desktop or use it Linux. Uh, it's basically depend on what type of images you are building. So most of the servers I see, if you are not specifically working with .NET framework, they are all based on Linux, Node, Python, .NET Core eventually also, which is a part of a Microsoft. It's actually started building upon the Linux one. So it doesn't matter that it's just not a question like what can be used. It's depend what you want to use, what sort of application you are deploying. It's totally depend upon that. That whether you use Docker desktop is just a UI interface provided by the Docker to basically provide you to not learn this command, that Docker build, Docker push, Docker this, Docker that, Docker run, Docker exe, Docker images, and all that stuff. So it's just providing you that. Can we keep multiple Docker file? You can, but I don't. Yeah, basically you can, because sometimes you have a different environment like prod staging, and you can do that stuff. But you have to be then specifically define what type of a Docker file you want to build it. Okay, the question is to the warning we get after Docker build. Question is penetrating to the warning we got after Docker build. Okay, which warning you want to ask about? This Windows against a non-Windows host? I don't get your question, Thor, I guess. Puneet Arora, if by mistake someone puts, which one will be picked? Okay, try to you can I think you can't put same file in a same repository. It will not able to create it, so it will always pick the Docker file because it start to searching the Docker file. So if you put it over there, try it out. I think you can learn more on that part because I never do that stuff to build multiple Docker files in the same repository. So try to do that. Okay. Okay, Jishan say yeah. Okay, so what question you have actually? I don't know. Okay, I think we can move the questions to the later part. First, we got to Darrow because you have a lots of more questions. Just queue your questions to yourself and just put it on after that so that we can answer on that. Yeah. Okay, so yeah, where we are. Yeah, so now we created that image from Docker build command. So you can see, I'm just write down the command Docker images. So what this does is listed out all the images present in my Docker environment. So you can see AWS User Group, which we have created this time. One, an image ID. This is basically the ID which is reference to that image. It's showing that this is the 3 minutes ago it's get created, and this is the size of that image, which is basically 170 MB. So it's basically you can deploy your node application in 170 MB only. In a virtual machine environment, you need operating system also for that, and it might create a havoc for you. So you just give the image only thing you needed to run your application, no more, no less. And now you also see the another image node 1311 same image ID, same the same that stuff. So basically this images come when we run the Docker file, which is needed to uh, need this file basically for the library for building your application. So it first downloaded this node image from the repository, then this build your image for that. So let's run that image. Okay, so for running that image in your Docker environment, you can use Docker run. Then you can put the name, what will be the name of that container, like it will be my app for me. Then publish is basically the port you able to access your application to. So like if I have so port 8080 is basically referring the port which is exported by my application, and this port 80 is basically the port through which I able to access that application. So it's like this Docker run their Kubernetes sorry Docker run all the containers in an isolated environment, and if you want to access those containers, you have to cross this Docker bridge. So this Docker bridge is basically exposing port on 8080. And on top of that, you are saying that if I want to access that application from my local system, I need to hit on port 80, and eventually that port 80 will hit the port 8080 inside that Docker. So I'm just exposing it to my local machine so that I can expose it to the another environment or my virtual network or something like that. Okay, and now where's that? Yeah, now I just put it's a detached mode, basically that I'm not exe basically to get inside that container to do stuff. I will show you in a bit how can I do that. And after that, I'm just mentioning the image name and the tag basically representing this image. I need to run this image on that board. Just it. So it's give me the ID that, okay, I run your code. This is the container ID for you. So I can see that container ID with Docker PS, and saying that, okay, this is the container container ID, this is the image, this is the command which is basically running. It is created 9 seconds ago, status up to 8 seconds, and you're saying that if you hit port 80, it will eventually hit the port 8080 and you will able to access those applications. So let's see that. Okay, host. Okay, so there is no endpoint for that. Data is their endpoint. So if I hit localhost data, is basically I'm hitting. So what happened is now, uh, yeah. So when I hit this endpoint localhost colon 80, you can't see 80 because it's by default port for that. So make it clear. So what it does is it hit the port 80, and then Docker knows that okay, there's a proxy and I am listening to port 80. Now it go when I hit port 80, it's go to the Docker runtime and hit that container which is exporting on the port 8080. And then I've just this is the API where I'm able to access this just dummy data which is key value. That's it. Any questions? I know you have guys lots of questions, but yeah, I think we can. Uh, okay, security warning. Security warning is just like this that you are running Windows host on, because I'm running on the Windows host and I'm creating a Linux image. So that's why saying that, oh, you are doing a wrong thing. You are building a Linux image in your Windows system. So that might, a warning for that might be file issues for that. Okay, why do we have two image in place of one? Okay, so like I said that so the question is why do we have a two images? Because I run only build a single image, and we got a two images, like Docker images. Let me put it again. Clear it first for you. So what happened is when I build this image, AWS User Group one image. So it's require another image, which is basically node one, which I refers to the you can say in the Docker file itself, node 13.11.slim image. So it's basically when I build it, it's need that image to build your application. So first what happened is it's go to the repository, it's taken that image node 1311 slim, and on top of that it started building that this is stuff, work directory, copy, npm install, and other stuff. So to basically build on top of that, you need that image in your system. So what happened is Docker first pull out that image from your, so that's why you are seeing that okay, now node image is also existing in your system because you needed to build the AWS user group image for that. Okay, this is this answer your thought? I don't know what's your name. So okay, Jishon, I ingress colon egress port. No, egress port is basically the outbound port for these applications. It's not like that. So we are saying that it's basically two virtual environment, you can say, not two virtual, one virtual environment of Docker. So you are exposing the port over there, and but that port exist only in that Docker environment, which you can see over here. Where's that? PS. So port 8080 is basically the port which is exist only in the context of Docker environment where all the containers are resides. So if you need to access those port 8080, you need some sort of a proxy to basically able to come under the Docker environment from your local machine. You will able to access if you are accessing the this container from another container in the same environment, you can access on the port 8080 because they are in same environment, and they do know each other that okay, you are listening on 5000 port, I am listening on 8080 port, so I can contact to you on HTTP port or whatever or whatever application layer. So when we are trying to export that port to the outside world, so we need sort of a proxy so that whenever I hit port 80, the network layer of Docker will basically mention okay, that's come to this container which is exporting on port 8080 to 80. That's it. That's why we need two ports, you can say. Any other question? I think I have. Nope, nope. Okay. So Docker run name port 80 port on local machine, expose port only in Docker file, detach. Here's the image we just built. Yeah, thought. Yeah, exactly. This is what we done. Okay, so again, if I run Docker yes all, this is the image, this is the container which is basically running. So now I'm trying to get enter into that container. So is basically that container is basically a runtime, so I can enter into that Docker container so that I can perform such steps. This is a great tool, regarding that. If you are using like if you're in Windows and you need some sort of a scripting tool to build on top of a Linux, like you are writing a script which is totally for the Linux and you have a Windows system. So you need to, move to the another OS, or sometimes you need to install some type of, you can say, subsystem or a virtual machine. Instead, you can use Docker for that. You can just get an image from Ubuntu, etc., from the Docker hub, and you can execute those commands. So let me do that. Okay. So Docker XCC is basically executing that stuff in an interactive environment and have a container name. So the name is this one, my app, and I need to execute bin bash. I need basically the terminal for that. So when I execute this command, what happens is it find my app container basically, and in my app container this execute execca command is basically you get inside that kernel of that container runtime you are basically built up with those image. And I said that okay, when you execute you need to execute this command, bin bash is basically the program where you have present in the Linux system, in a Linux operating system, which is basically have the, you can say, code for running your shell, basically the CMD, you can say, equivalent to in Windows. So now over here we are. So if you can now do basically the Linux command. So I'm on Windows system, with having Docker, I able to run Linux command in my, PowerShell, you can say, not in PowerShell but in that context. So totally I will able to run this command. What is the, I can run this, I can see the whole directory, which is basically the native directory structure of the Linux one and all that stuff. So it's great tool to, build those applications. That's the beauty of the Docker. You can basically go from another environment to another environment, and by does not hampering your system at all. So like I can do exit from this shell, and I can stop this, basically this container, Docker stop, and my container, what's that name, container, my app. So it will be take few times, take time to stop. Yeah. So if I run again Docker ps, basically SR, you can see that though that container is not running, but you can see the stop running also with dash all command, which is basically print out the all that containers exist in your system, is saying that you are exited 17 seconds ago. Now you also can remove that container, basically Docker remove, and my app, which is a container name. Now it also remove it from your system. So now basically you are in the on the blank state. There is no container running on your system. In just two steps, you run your scripts, you do your stuff, then remove it. That's the beauty of that. That's the beauty of the Docker itself. So I think yeah. uh, any question regarding the Docker? Okay. Let me go to the chat again and see, is there Docker image difference between Docker PS and Docker PS all? Okay. So Docker PS is basically show you the containers which is actually running in your environment, only the running containers. And Docker PS is all, PS dash A is basically PS dash all, give you the all the containers resides in your system, whether they are stop or running. That's a just different. That's a just a flag for basically representing that. So I use git bash for running Linux commands. Yeah, you can. I'm just giving that example that you can also do that stuff. That git Linux basically is also the sort of a subsystem which is based on a virtualization. You can't run all the git Linux command on git bash. Bin bash is equivalent to shell. Exactly. You can run sh also. It basically eventually called the bin bash. Docker ps will show running containers. Exactly. Okay, so I think, oh, sorry for that. Docker ps Docker images. Now we have this image. Okay, so I think this done for the Docker. Let's move the first. Let me have any you guys another question. So we can move to the Kubernetes part regarding Docker. Any other question you can put it on the chat. No, okay. Let's again move to the, I can say, to the, okay, where we have what we have done. Okay, Kubernetes. Okay, so how many guys you know about the Kubernetes? What basically comes with the Kubernetes? What actually problem Kubernetes trying to solve? We have Docker, but why we need Kubernetes? Any of them? Puneet is saying Docker inspect, but in Alpine we don't have any bash, right? Yeah, Alpine is basically a little, slim version of these Docker images. It's basically depend upon you how you are basically using building your applications. So Alpine is the most secure way. It's have a minimum dependency related to Linux system. So if you're using Alpine, you can install it. It does not that you can't install it on top of that, but Alpine does not come with that. It's basically to reduce the security risk for your containers. So that's why they are not providing bin bash. I think they don't even provide the curl command in the Alpine. Okay, so yeah, I'm getting lots of Kubernetes. Yeah, for orchestration, Kubernetes use container orchestration tool, orchestration. Okay, orchestration. Yeah, everyone is saying orchestration. Okay, so I think you get it right. So what Docker is basically doing it, you creating the Docker containers, you can remove it by the command lines. So Kubernetes, so what happen if your Docker container have some error, it's running and you hit a REST API and it's just broke down and it just get hampered on that. So it it just stop that container will be stopped and it not try to restart it not try to basically HA environment. So you need some sort of a tool which is basically do that step to those steps to you. Like if the container is get down, create a new container, create a multiple instances of that container so that your application is on highly available. High available means you have a multiple instances of same application, so if a user comes, it can go to the any of the instances and get work done with it. So basically Kubernetes is what done is it's orchestrate, you can say, it orchestrate all these containers, so that one containers get down, you can spin up another container, you can deploy multiple containers at a time in a distributed manner. So Kubernetes comes with a lots of machines. You can have a 3 to 4 machines basically who are building up your infrastructure, and on these 3 to 4 machines you're deploying your containers. I'm talking about the high scalable production level applications which have a lots of application, and you need multiple applications at a time, instances of an application at a time, like 8 to 10 to 3 to 4, whatever it is, and one gets down, you can spin up quickly a new one. So as we know that containers are lightweight, so it get spin one, but we need some orchestrator who will do that, because we are not going to sit there and see, okay, this container get down, now we have to restart it in a production. We need to automate that process. So Kubernetes does that for us. Okay. Another question is, Kubernetes run across a cluster? Actually, Kubernetes is a cluster, so I didn't get your point, Ananya. I guess Kubernetes run across a cluster. Can you rephrase it? Okay, Saksham is saying management of containers. Yeah, management of containers. Absolutely, that's it. Jishan asking, do you think AWS behind the scene uses Kubernetes for EC2 autoscaling, etc., or Lambda? I don't know actually what they are running behind the scenes for scaling up EC2 autoscaling. I actually don't know, because that's not a public, I think, public information how they are doing it. Okay, so did you guys get the point of Kubernetes? What we have in Kubernetes? Okay, I think, yeah, get that. Let me move forward. Yeah. Again, why we need Kubernetes is basically, so as I told you that we can we can orchestrate the multiple containers, get deleted, spin up new containers, then basically handle our deployments. Like if we have a new code push in, new feature is come to that application, we need to deploy that. So streamline that whole process, deploy new features to the application, then deploy on the top of the Kubernetes cluster, and make basically our life easier, you can say, in terms of orchestrating container and deploying those things. Okay, now here's the terminologies which we you heard most of the time. There are various terminologies in Kubernetes actually, but I highlighted the, you can say, basic one, which is basically most of the use in the Kubernetes cluster. These are pods, deployment, and services, and kubectl is basically like the Docker CLI command. So kubectl is basically how you interact with your Kubernetes cluster. Pods are basically the smallest unit. Like in Docker, you have containers. In Kubernetes, you have pods. So inside pods, you can run your containers. So you need at least pods to basically deploy your applications. Without pods, you can't do that. This is basically an atomic figure in the Kubernetes cluster, that you need pods to basically deploy your applications. Deployment is basically, you can say, a number of pods. Like I have an image, and now I want to deploy that image in a Kubernetes cluster with three instances. So I can use deployment and said that, okay, I need 3 replicas of this, I need 4 replicas of this, and eventually Kubernetes do that for you. It basically create 4 instances. Like in Docker, I have to run explicitly that Docker run and this. I can't mention that you can run 8 instances of that. But in Kubernetes, you can run multiple instances of a single image based on the deployment. And service is basically the how you basically accessing those containers, those pods, those deployment. So like, is there's like containers, then pods, and then replica sets, and then deployment, and on top of the deployment you have the services. So there are multiple services: cluster IP, node port, and load balancer, and all that stuff. So you can access those services, and through those services you can access your pods, your applications. Okay, so here's a question. Please explain about pod, inter-pod communication, and clustering using Kubernetes. Okay, about pod, inter-pod communication. So are you asking about the how multiple containers in a pod communicate to each other, or how the different pods communicate to each other? Let me explain both of them. So if in a pod you have a multiple containers, like 3, 4, 5, whatever you wanted, but it's preferred that you should not have a more than two containers on a pod. So these two containers in a single pod can have access each other on the local host. They have a same network, they have a same NIC, but they can access, like if I there is a container A and then is a container B, and they both resides in a pod. So you can just contact via the localhost A, localhost B, and you can able to, it's discoverable at a pod level. For intrapod means one pod is communicating with different pod. You can use the DNS and IP address allocated to the pod itself. So there is a DNS name basically configured at the Kubernetes CNI level, which is basically the networking level of Kubernetes, where every pod gets a new IP whenever whenever it's spin up. So you can use that IP address and then your port, basically on which port you want to communicate with them. Okay, let's this is the architecture of Kubernetes. So how is basically Kubernetes is designed, how it's do that stuff which we are talking about. So you can see the kubectl at the top. Kubectl top is basically the CLI tool, CLI command line, which you do that stuff with you. Basically, you write kubectl command to interact with your Kubernetes cluster. And how does that work? You do kubectl get pods, like you want to know how many pods are in the system. It go to the kube API server. Kube API server is basically the central managed identity, you can say, where all the REST API request comes from the kubectl as well as from the different components in the Kubernetes cluster itself. There is then etcd. Etcd is basically, you can say, sort of a database which store all the information regarding the cluster, like how many pods are there, how many config maps are there, how many deployments are there, how many nodes are there. Node is basically the how many machines you have. Then we have a control manager. Control manager is basically the, you can say, a process which is basically checking the Kubernetes cluster, that okay, that pods need to have a 3 deployments, that 3 pods, 3 replicas. So it send request to the kube API server. Okay, I need this image have a 3 instances in a Kubernetes cluster. Then we have a kube scheduler. Kube scheduler is basically where should these pods get reside. You can see there are two node basically. So where should that pod goes to? Node 1, node 2, and it tells to the kube API server that okay, you need to schedule this pod in node 2. And then kube API server is basically send a contact with a kubelet, which is basically running on every machine present in that Kubernetes cluster. And that kubelet is basically responsible for regularly means sending data for particular node to back to the Kubernetes master nodes, master management, or the brain of the Kubernetes cluster. I think that's it. And there are pods, there are kubelet who's basically doing that stuff. There are end user and load balancer, which is basically on top of your application so that you can access your applications. Any questions on that? Or we can move to the hands-on part. Okay. I guess we can move on that part. Okay, let me come out from this. Okay. So first thing first, let me clear it. kubectl. So it is basically, kubectl is basically the as I said, that is basically the run. So basically, you can see the screen now, right? Okay, yeah, it's good. So kubectl is basically the CLI command line through which you can access your Kubernetes cluster. I created already a Kubernetes cluster in Azure, so that for this demo purpose, you can use. You can make your system also, to basically as a Kubernetes cluster by a Minikube. And if you have Docker Desktop does also provide that. Unfortunately, I can't install Minikube in my system. So I'm not able to run those commands in my system. But eventually, I created a Kubernetes cluster for this demo. And I can show you little bit. Get pods. So this is the basically I'm getting the all the pods running in my Kubernetes cluster, which is basically doing the all this stuff which we have to do to perform an application. We will deploy in a bit. So okay, so now what we have is Kubernetes YAML. Yeah. So we basically deploy. Just should I increase this size? Yeah. So to deploy the applications on the Kubernetes, we use it a declarative way most of the times. Like in Docker, we are doing a CLI commands. On Docker also, we can use Docker compose files to basically deploy those. But we eventually don't do because we don't have that much complexity in that. But in Kubernetes, we have to deploy various applications, various replicas of that, various things, various services, various config maps, on all that stuff. So we use it the manifest file, you can say, or the declarative format for the Kubernetes. So here it is. You can see. Let me go again, like one by one with this. Okay. So firstly, I think I should run kubectl. Kubectl basically the CLI, as I already told you. So if you want to see that how you can interact with what are the basically the commands for it, you can run kubectl help to basically find out all the commands you needed for that. So in deployment, so deployment is basically the like if you want to deploy your application on the Kubernetes cluster, you write a deployment. So deployment is basically you can say how you control how many replicas, how you want to control your applications in a Kubernetes cluster. So you can see this is just a manifesto file. So you don't need to memorize it. You get a pretty on that. You just need to understand what each and everything is meaning. So this is the API version. It's basically describing that okay, I need apps 1v1, which is basically the version where deployment object this kind is exist in a Kubernetes cluster. So Kubernetes basically work on the pluggable feature. So new features is coming around every day in Kubernetes. So under the various API version. So each object like deployment or you can say service have a different API version. So you need to mention that okay, I need this API version and I need this object to deploying my Kubernetes deploy my applications on Kubernetes cluster. And then we have a metadata is basically the deployment any information regarding that deployment like name, and then we have a labels to basically stream out that how this deployment is basically labeled to each other. I will explain it later how this labels is basically working out with finding the services. Then we have a basically specification for this deployment, like I need two replicas, I need two instances of that image. Another one is match label selector is basically, so there are multiple pods running on the Kubernetes. So I need a selector to basically identify which are the part of a same deployment, which pods are basically part of a same deployment. So this label app demo app basically is uh, tend to decide okay, we have two replicas, and because every time the pods get destructive created due to some error or something like that, so due to this label it able to recognize it, okay, these two pods are part of this deployment. And this template is basically you are seeing is basically the form of that what sort of application I want to deploy, what will be the command line for that. So I'm just you can see the containers is there, you can deploy number of containers. You are mentioning that okay, I need to export port 80 from this container. This is the image which I'm using in Nginx. It's a basic HTTP proxy image, which is basically for a testing purpose, and you can use it for basically creating a proxy on top of your applications. So this is just a deployment. So deployment eventually deploy you the pods. It's not basically able to create you can say how to access them. For accessing those pods, you need a single entity point, because you have on two pods. Now you want to access those application which is resides in that. So how can you access it? You can access it by creating a service on top of that. So you eventually hitting the service, and eventually that service is hitting your pods and getting your data written from that work done by that. So here is the service specification. So I'm just let me start with the pods. Same with the API version, you can see V1. So in the V1 category, there is a kind object which is present as service. Metadata is basically the name you have provided the service. Now again, the specification. Type is load balancer. So we have a three types of services basically resides in a Kubernetes cluster: cluster IP, load balancer, and node port. Actually, we have four, but these three are the most common you will see. So load balancer is basically used to export your application to the outside world to, so that we and you end user can use it. Another one is cluster IP. I will show you in the demo that how this IP created. Cluster IP is basically for that how the multiple pods basically interact with each other. So the cluster IP is basically resides only limited to the Kubernetes cluster itself. So when you hit the cluster IP, you will in from the Kubernetes cluster itself, you will able to access it. But that does not mean that you can able to use it from outside the world, because it's private IP addresses that does not resolve from the public endpoint. Then we have a selected. This is basically the you can say the label which identify, okay, which pods uh, are part of my services. So app demo app. So if you see, you can see the labels are matching app demo app. So basically this label is basically help the service to decide, okay, I have this pod, so every time request come to the service, it transfer that request to these pods which have a label app demo app. On this base selector, basically it decided that. So ports basically, target port is basically on which port from backend application you are basically exporting. It's similar as you can say where we have a Docker, that we have a published port and we have a two ports basically. So target port is basically the equivalent port of the container ports, and another port 80 is basically how the service will be accessible to the end user. So if we hit port this 80, we will able to access this service, and this 80 port will be able to access the container port actually from the application itself. So when we hit port 80, it eventually hit those port. Okay, any questions? I know that's a tricky one, but yeah, we will get into the demo so you will able to understand more better on that. Okay, I think Ankit is asking, so from manifesto, basically, are we creating container two instances from an image? Yeah, we are basically doing that stuff. So yeah, so how we are basically do that? So we do with the kubectl, there's popular command apply -f, and then we have Kubernetes get XML. So what basically this command recite is, I'm saying that apply this config -f means file from this file basically, which I'm showing to you, this one. So apply all the configuration present in this file to this Kubernetes cluster. So it will be eventually create those resources which is resides in this configuration. So if I hit enter, you can see it's saying that deployments get deployment demo app is created and service is created. So if I write kubectl get deployment, it will show that okay, you have named demo app deployment, which have a two pods basically in a ready state, up to date, available, and just created in 14 seconds. Okay, there is another question: two container instances or two pods. So you define at the pod level that how many, because pods is atomic terminology in Kubernetes. You can't divide pods. You, if you want to deploy your application, you at least need a pod, and inside that pod you can have a multiple containers. Let me show you again. you can see this containers. So this is basically the specification for a pod, and you have a containers, it's a plural, so you can have a multiple containers inside that. So when I'm saying that deploying two replicas, it means I'm deploying two pods of this same configuration, of this highlighted configuration. How to export load balancer, for example, ALB or LNB in a manifest file. Okay, this is, I'm actually doing it. I'm just showing you in a bit regarding that. I'm coming on that point actually. Good question. Uh, okay, so let me run kubectl get pods. You can see two pods is basically created. It's saying that 1/1 is basically that this pods only have a one container. It's stating that this information. So you can see the two pods created with the same image, which is a nginx one. And now kubectl get. Let me show you one more thing. Yeah. So this is just another command, which is I do kubectl get pods dash o white, is basically print out all the other information related to the pods. So you can see pod name, running stuff, and this is the basically the IP 10.244.0.10, which basically make accessible that port from the service or from any other application you wanted to use. And this is a node, is basically the node on which it's basically a server on which the pod resides. Now let me run kubectl get service. So here you can see the service. This is the service which is basically get created to accessing those pods. Let me highlight it this. Yeah. So you can see the type load balancer, and then you also see cluster IP 10.0.173.56. So what happens is whenever you create an service, it's eventually create a cluster IP. Cluster IP is basically means it is accessible in that particular cluster. So is, for example, if there is any another application who try to uh, connect with another application, so it can use this cluster IP on, because they are on same network, they can use this cluster IP to basically accessing that application. It will help you it basically get that result from it. And external IP is basically we are exporting it to the outside world. So if I just copy this IP address, control C, and let me, okay, share you the browser with it, you guys. And if I hit this, basically able to access that application, which is basically a nginx one. So this application is basically running on the Kubernetes cluster, and then able to access with my service, which have a IP address 20.207.78.53. Yeah. Again, where's the command line? Yeah. So any questions on that part, or let me see the chat box. Yeah. Okay, and also in Kubernetes, we need to install third-part networking like Fennel or other when we are not setting up in Azure or AWS. Yeah, okay, so Fennel and this type of tool like Calico, they are used for the, how these communicate with, how the different pods and services communicate with each other. Also, they also use for enforce network policy in your Kubernetes cluster. Like for example, you want that, okay, this pod not does not need to require to connect with these pods. So you can create you can say sort of a firewall through the network policy, so that these two pods does not can talk to each other, you can say. So Fennel, Calico are doing that stuff for you, rather than doing it manually by creating because they all are the virtual IP addresses, cluster IP, and all that stuff. Okay. Any other question regarding the Kubernetes or Docker you have, guys? You can ask me. have that. Okay. So, okay. So one thing I forgot to tell you regarding the Kubernetes service is that you can see this port, port 80 and 30820. So what happen is when you're trying to accessing the application, instead of how it get export, so that application is basically running in a pod, and pod resides in a virtual machine. So what happen is Kubernetes what does for you, it open a port on that virtual machine, which is 30820 in this case. And and on top of that there will be a load balancer. So when you hit port load balancer on port 80, then it eventually go to port 30820, and eventually this port is basically listening to your application or to the pod itself. I know this is a various virtual layers on top of that, but yeah, this is how Kubernetes works. I know will be a tricky point, but yeah, if you get to know it, it will be better. Okay, there's a question. On what basis does it assign the IP addresses? Okay, so when you create a Kubernetes cluster, so you provided the IP address range. Like if you heard about the private IP addresses, so there are two type of IP addresses: private IP addresses and public IP addresses. Public IP addresses are, you can see when you basically communicate with all the websites, are basically hosted on the public IP addresses, have a server which is basically registered to it. Private IP addresses are, like IP addresses through which you can create your own network. These are the three ranges for that, which is provided by the, I think, IANA. Uh, so you can set up all your networks due to that, but they are not discoverable to the outside world because they are private IP addresses. So like this IP address is 10.244.0.10. These are the private IP addresses. You are not able to, find any public IP address with this range 10 or 192 or I'm forgetting the last range. Sorry for 172. Yeah. So these three ranges are basically all are the private IP addresses. So when you basically uh, configure the Kubernetes cluster, you assign the IP address range to them. Okay, this is the IP address range for you, and you need to use this IP address range basically to deploy to basically when your Kubernetes, when your pods will be there, when your services will be there, you need these IP addresses to basically assign it to them. So there is another networking pod running on the Kubernetes cluster, which will basically acting as a DNS server, NAT, which is doing that stuff for you, like your router does for your home. So that is basically using that algorithm for how to assign which IP address and all that stuff. Yeah, you can have a different range for Kubernetes cluster. It's totally depend upon you, but you have to choose between the private IP address ranges. This is for all, not for just Kubernetes, for all the private server also, all the virtual machine also, that you need that private IP address range. Yeah. Any other question regarding Docker, Kubernetes? Any other question? Okay. Okay. I guess we can ramp up now. Uh, Saksham, do you have any question? Yeah.
Yeah, sure, sure. So, guys, if you have any question, you can ask, or like we can just wrap up the session. So, before leaving, we have just sent the feedback form in the chat. So, please do fill it so we can just know about your reviews. And like on the behalf of the whole AWS User Group Dehradun, I would like to thank Girish for such an informative session and for sharing such great insights. And we are really glad that you could set aside some time from your busy schedule and be present here with us. And it was a complete pleasure to have you among us, and looking forward to having you again. And thank you all for attending the session and making it more and more interactive by asking questions. I hope you all enjoyed and all your doubts would be clear. So yeah, this is like the end of the session, and we are formally closing it today. And before just leaving, just fill up the form, guys. And this was all from our side. Thank you all. Thank you so much, Girish.
Thanks a lot, Saksham. It's my pleasure. Definitely, I will. Maybe we can connect future. If you guys have any question, you can connect on LinkedIn and you can chat on that, and or I will post it a Slack group so that we can talk about the Docker and Kubernetes stuff also. Okay, I guess I should
Yeah.
stop sharing the
Thank you.
screen. Yeah, thank you. Have a nice day. Bye bye.